Hello, my name is MF Aman and my IT number is IT22353498. Let's walk through of our CNN for brain tumor detection. We classify the MRI slices into tumor or no tumor. So first of all, we just mount the Google Drive to get the data set, and then we clone our repository in order to run the necessary scripts, and we install the dependencies, and these are the record libraries, and then we set up the paths. After the pre-processing, the data are stored in the Google Drive, and also the results after the training and evaluations are also stored in the Google Drive. So the paths are set here, and then we just process the data. In here, the input images are resized by 224 by 224, augmented with flips and rotation, and also split the data into training, testing, and validation. And then before we train using the CNN model, we just built the CNN as a stack of convolutional blocks, followed by a batch normalization and a ReLU activation, excite special features, and putting less progress to reduce the spatial resolutions. And then we used to train the model. In here, we use CNN, and also we use the batch size of 32 and using epochs of 20. So during the training, the model learns by minimizing classification loss. We compile with an Adam optimizer and a categorical cross entropy loss. Then we feed the network with the mini batch of augmented images with the uh, multiple epochs. So after the training, we just have got the accuracy of 93 0.93, and after that we used to evaluate our model, and after the evaluation we have got some results, and this is the training history of our model. This is our confusion matrix, and also this is the ROC curve that we have got, and this is our classification report of our model. That's all. Thank you.
Hello everyone, I am Mohammed Mufiz. My IT number is IT22320896. I have used VGG16 to train the brain tumor classification model. Uh, in VGG16, it has already over 14 million images, so it converges better than the CNN model. This is the class I have used for the building the VGT16. I have used Adam for uh, optimization. I have reduced the learning rate for fine tuning better. And this is the class I have used for the training the VGG16 for the brain tumor classification. It will show the whether it's yes or no when we check for the brain tumor. Then this is the model for the evaluate the evaluate our train model. Then when it comes to the notebook, uh, here here we are loading the data, and we are using the pre-processed data. After that, we are setting the batch sizes and epochs, the and the learning rate. Then here we are checking the GPU whether it's available or not. for the fast training. Here we are checking the available data for training and validation, then testing. We can see for training there are over 1,000 data, and for validation and the testing. Here we are training the VGG16 model. We have found the best model with the accuracy of 0.98. The model is saved in the drive, Google Drive. So here we are evaluating the best model with the testing data. This is the evaluation report, and the test accuracy is 0.97. After that, here uh, we can see the graph accuracy over epoch. Here we can see how the accuracy going high when we increase the epochs. After that, these are the images, sample images to predict whether it's correct or not. Here, this is the brain tumor. This is the image with the brain tumor, so it predicted correctly. After that, I have added a code for manual testing also, so that I have uploaded two images manually. So it has found this image is with no brain tumor, so it has found correctly. Um, then this is the image with the brain tumor, so it has detected the brain tumor. Thank you.
My name is Shukri. My IT number is IT 220 52 124. I'm done ResNet 50 transfer learning model to brain tumor classification. This project uses deep learning to automatically detect brain tumors from MRI scan. And let's walk through the notebook. And here we mount our Google Drive, and we clone our repository to get access for ResNet 50 models. And here we set up preprocessed data directory, because preprocessed data already in our Google Drive with all the text data and validation data and training data. And here you can see how we have total of 302 images that is split into training and validation and test images. And here we used for GPU for to check what's run on to train. Use GPU. And here we data process to check the is available or not. And here is the preprocessed data structure. And here is the training ResNet 50 model. We used two-stage training strategy. Our first stage does train classifier header, freeze all ResNet 50 base layers, and only train our custom classification layers. With higher learning rate, this stabilizes the new layers first. We train first stage with 80 pods, and second stage for fine tune the deep layers, unfreeze the last 80 layers of ResNet 50, and fine tune with the lower rating learning rate. This adapts the model especially to brain MRI images. And this two-step approach prevents the pre-trained weights from being corrupted early on, to leading to better final accuracy. And here step 2, train with 20 pods, and you can see the output of these. And here you can see the first training stage 1 with 80 pods, and stage 2 fine tuning with 20 pods. and we can see the best validation of 0.994. This model saves in a drive result folder with ResNet 50, and using that model we evaluate and get and some test result of accuracy of 0.09978, and this is the classification report. And you can see after evaluation the graph. For stage 1 you can see accuracy and epochs of the training and validation data, and after for fine tuning stage 2 accuracy and epoch of training and validation data. After these are some report for confusion metrics, and here is the classification report, and these are the sample of testing predicting and predict accurately. And I done a manual part to manually upload an image and check it's predict correctly. It gives accurately with the confidence score of 0.998. And these are the model, like this is fine tuning stage 2 model, and this is the stage 1 model. It use the Adam optimization. And thank you.
Hello, I'm Shadir Fawz, and my IT number is IT 222 and I trained an efficient NetB0 model for brain tumor classification using MRI scans, and it allows me to get an accuracy of 97 accurately approximately a 97% of accuracy. And I started selecting this model is because it offers a great balance between performance and efficiency, and also it's lightweight, and because of that it just took 5.3 approximately 5.3 million parameters, but still it delivers the state of the art results. And I use transfer learning with ImageNet weights and added custom top layers where the global average pooling, dense with ReLU and batch normalization, dropout for preventing from overfitting, and a final sigmoid layer for binary classification. And the data and the GitHub repository is shown over here, and then I added needed dependencies, and then load the preprocess dataset over here. And I started training just by splitting the data into uh, train validation and test in the ratio of 70%, 15%, and 15%. And I applied preprocessing with efficient nets preprocessed input function to ensure consistency. And to improve generalization, I used data augmentation and rotation, zoom, uh, and then the horizontal flip, brightness and contrast adjustments. This help the model learn robust features across varied MRI scans. And the three steps I have carried out three steps of training process. And the stage one, they trained only the classifier head with the base frozen, and this gives me a starting accuracy of 73%. 73%. And then the second, I unfroze the top layers and fine-tuned the lowered learning rate, and it took me an average of 75%. And as the third step, the training process, I unfroze the entire base and then fine-tuned with an even lower learning rate. And this final stage pushed the test accuracy to approximately 97.5%. And I use callback like early stopping and reduce cellular oil plateau and model checkpoint to stabilize training and avoid overfitting. Thank you.